So today the first half, the first 1 hour is going to be about cloud computing, and this is something which is gaining a lot of popularity nowadays for the last few years, since people have started doing heavy duty computing. So this is 24A, lecture 24A about cloud computing. So we'll discuss two cloud computing resources. One's Amazon Web Services, the other is Google Cloud Platform. These are one of the popular ones available in the market, but there are other as well. I said no discussions please, thank you. So there are others as well, such as Microsoft Azure and others. So you can explore them as well depending on the pricing model and your requirements as you need them, but we'll discuss these two with the demonstration. So the motivation behind cloud computing is that computing slowly is turning into a utility, like you utilize utilities like electricity, water. You don't own a power plant, you just use the electricity which is supplied to you through the grid, and you pay for whatever you use. So it's a service rather than buying infrastructure. And one of the major reasons for that is because computing resources, they get outdated very soon. I mean, if you buy latest whatever technology is available in the market, which is very expensive as of now, within a few years, literally within 3 to 4 years, that becomes very cheap, and you have other new technology available. You can see how the Intel chips are developing and so on. So the whole idea is that why spend a lot of money if I don't intend to use it heavily? If I plan to use it 24/7, that's all right, maybe that makes sense. The return on investment is good. But if I plan to use sporadically, then maybe I can spend that money, a part of it, to run the codes on a cloud, and then whenever I need resources, typically the cloud pricing is such that I get latest resources at a certain price. So after 4 years, if I need the resources with a similar price, I'll get a better infrastructure, better speeds. So it's good to rent computer time by the second or the hour. Usually it's by the second in most cases, with some minimum time for billing. So you can use that, and that in many cases will make sense. So whenever you expect peaks or bursts of computing power requirement on your end. And other major benefit of this is that on these cloud computing services, you can make virtual images or machine images, like you have a virtual machine for your course that I have shared with you. So you run basically machine images, which are like virtual images, and then you can run multiple instances of those. Well, hardware wise, you can only have one computer and you can run one OS on it. But image wise, you can simply copy those files which are running as machine images, and then you can run as many as you want. Okay. So if I have to run a code, let's say on different instances, I can simply create one machine which has all the installation required, and I can simply copy it multiple times or run multiple instances of those. It's like as if I'm running different computers with the same settings and with the same hardware and software settings. You can even share that with the others. You can actually put that on some sort of hub where people can download those images and run them. Okay, we'll see through the demo that some standard images for certain installations are available pre-installed, that you can simply import and start running. And well, just some history behind this. Amazon Web Services, the name is a bit strange. I mean, it started at, I think this is one of the first ones which started cloud computing ideas for computing as a service. Amazon was mainly into the business of hosting web server. Okay, so they had bought a lot of resources, servers and stuff for running websites with their website. But what they realized was that there are times when they need a lot of computing power for it, or they are paid for the maximum size they want, but there are times when they don't even need that. So why keep it sitting idle? Why not start renting that computing power? And through this Amazon Web Services started, as a cloud computing model, and then the other companies also caught up because they were also buying resources for their own um, for their own storage requirements or compute requirements and so on. Okay. And sometimes the pricing model is such that I mean, if you don't care about when the code should run, then in many countries even the electric power is based on peak non-peak hours. So there are times when very few people are using it, so prices automatically start falling down. So similarly, it happens here that whenever the prices are low, you can have some sort of metering that it will automatically start running your code, and that's when the pricing will start getting calculated when the prices are low, if you don't care about this. Okay, so these things are possible if you explore these cloud computing resources. Right, so Amazon Web Services, there's something called Amazon Elastic Compute Cloud, EC2 as they call it. So this allows for cloud computing. They also provide you, if you want to host a website, well, then they basically provide you with some quick and easy ways to create public IPs that you can use to, and in fact we will see that whenever with the cloud computing instance we set up, we will also set up a public network address, and what we will do is the results we get from our codes, we will put that on a website, and from here I will open that website and see the results. So that's how you can have and you can have expandable storage. So you can start with some storage, but later you realize that you need more storage, so you can simply keep expanding it, because this is a virtual machine that's given to you. Maybe the storage they have available is a large one on a parallel file system, so you can keep expanding it. So it's elastic computing and elastic storage, expandable storage. So let's have a look at EC2. So this is let's increase the font size. Well, hopefully people at the back can read, but you don't need to read everything in detail. So what you'll see here is on the Amazon EC2 page, you'll see some instance types. So you'll have some organization based on compute optimized, memory optimized, or a complete list is also given if you want to explore through that. So let's say we want to use something which is compute optimized. So it gives us these options, and then it provides you details of what this C7G instances are, what sort of processing power they have, and so on. And then within that they have some subdivisions that C7G has a medium, a large, an extra large, 2XL, 4XL, 8XL. So that will define how many CPUs, or in this case it's virtual CPUs, but for you it will be as if you have a CPU. So they have these many CPUs, how much memory is available, so you can go as high as you can go as high as you want, but then depending on that you'll have to choose. So if you want to go to memory optimized, then you may have ones which are high memory nodes. So if for one particular simulation you need a high memory node, then you can get 3000 gigabytes and all the way to 24,000 gigabytes. Okay. So this is huge amount of memory you're talking about. Of course, I mean they'll charge you for it, it's not free. But the point is that depending on what you need, you can choose from here, and there's plenty of stuff available. For today's discussion, we'll use something that is free, because I don't want to pay for this lecture. So there are some instances which come free for 1 year. You have to use a credit card to start an account, because they hope for the fact that you may exceed that free limit, and then they'll start charging you on the credit card. Okay. So if you plan to use it or try it out, try it on your own risk. Read the terms and conditions properly and make sure you close your account before that 1 year trial period, otherwise you'll start getting charged. Okay. Right, let's explore this page a bit more. So there's pricing here. Look at the pricing plans. We'll go through it. We'll whenever we start the instance, they're nice enough to tell us how much will it charge before you start running the instance. So instance types, I think we've had a look. So there's plenty of stuff to read. And I'm sure if you really want to use this service, you'll want to go through these things, including the frequently asked questions. So on the slide, we have this free tier on EC2. So on EC2, as I said that some things are free, at least for the first 1 year. The only thing is after 1 year, they'll start charging you. So you have to create a new account with a different credit card. But hopefully by 1 year, you'll like it so much that you'll want to, because free stuff is very trivial. So if you really want to use it for something useful, you'll have to start paying. But the prices are so low that you'll even feel that they are good enough for your projects. Okay, so this is AWS free tier. So free tier has some detail, AI, machine learning, database, DevOps, analytics, whatever there's plenty of applications, and based on that they'll tell you what sort of free stuff is available. So let's say we want to do computing. So we'll go to this thing called compute. So here if you click it, it will filter these free tier facilities that they are providing you from the computing applications. So it says Amazon EC2 750 hours per month free of Linux, T2 micro or T3 micro instances depending on the region. So T2 micro is free, and later we will see that when we are selecting the instance type, it will tell us which ones are free. Okay, so 750 hours per month of certain instances are free. Beyond 750 hours, they will start charging you based on some pricing that they have. A total of 50 gigabytes of storage is free. Okay, some amount of communication, because input output is also charged. So there are lots of things which we have to take care of that. I mean, for these trial and demonstrations, we will not go beyond that anyways. So even if you want to try things out, you can try them without paying any price, as long as you make sure that once you're done, you have to stop the instance, otherwise it keeps running on the server. Let's also have a look at the pricing model that they have. Let's see. So they have something called on-demand pricing, savings plan, and spot instances. So spot instances are 90% cheaper than on-demand. You run them when you need them, whenever demand of computing. So then you can go here, you can filter things out based on which region. So let's say so this region where the hardware is stored, and depending on the region the prices change. So you have to explore that a bit. So let's say we choose US East, and we'll want to run a Linux OS, and then I would want to, well, let's look at the options available. So it says that for example T4G.nano has an hourly rate of $0.0042. So $1 is 80 rupees. So you can calculate for hours, it's almost nothing. Okay, it gives you two CPUs with half a gigabyte of memory. Well, then half a gigabyte is also nothing, right? So let's say you want to go to 32 gigs. So 32 gigabytes with 8 cores is 0.25. So around 20 rupees for an hour. That's not too much. If you want to run it for a few hours, then you'll be paying around 100 to 400 rupees. Let's say if you want to run a code for some hackathon or some competition, then it's good enough, rather than trying to run it on some cluster and you're not getting resources there. Or you'll see that installing stuff also is very comfortable on these platforms. Sometimes you'll have pre-installed instances available. Okay, so it's actually much cheaper than what it appears when you start seeing the complete picture. So as I said, please make sure to see the pricing before proceeding. So let's start playing around with it now. So well, as I said, some images are already available. So let's have a look at some images that, lots of images. So we'll have to go to this marketplace. Now it has lots of stuff here. So we'll have to go to the AMI section, which is Amazon, which means Amazon machine instances. And here again you can do some filtering. So let's say I would want to I'll filter with free stuff. Okay, so whatever is free, I would want to have a look at it. So let's view all the results. So I get a total of 4,133 results, but now I can do some more filtering. So I would want something which is available for OS Linux. So then that brings it down to 761. Now I would want only Ubuntu. So let's filter that further. So I would want to look for Ubuntu based images. So they are basically installed on Ubuntu because I'm comfortable with that environment. So I get around 241. Now we can go down further. So who is the publisher? So there are different publishers, different companies. So I would want to go for Canonical. Canonical is the one that develops Ubuntu. Okay, so that's definitely an image which would not have any fishy stuff in it. Because you have to remember that as well, that if somebody is sharing their images, so you have to make sure that there's nothing unexpected. Now architectures, so there's some for ARM, some for x86. So I would want to go for x86 because the kind of software I would want to, let's say, work with is available for x86 only. ARM is another architecture. So typically your Mac, etc. will run ARM. And then, so how many do we have now? So we have 14. So I think that's a good enough number to shortlist. Is there anything else I can do? So I think that's enough. So let's look at this. So they're all Ubuntu, and now let's look at the versions. So let's look at the newest listing. What's the latest one that's available? So 2404 LTS. Okay, that's what I want. Okay, I've been running 2204 for some time. This is 24.04. It says minimal, but I don't want to. I am happy with all the lots of stuff installed, pre-installed. So I'll go for 24.04 LTS Noble. Okay, so this is what I want. I'll click it. So now it says, well, I think I have not logged in. Right, so this is, so now I've logged in. So now it gives you the pricing. So on let's say a T2 micro, which is what we will be running today, it doesn't show that. So let's say on a T1 micro, the software is free. You don't have to pay for the software. The EC2 charges are 2 cents, $0.02 for 1 hour. Okay, so this is the pricing that you'll be paying. Actually, it's 0.096. No, this is the actual price. But it says free tier. So EC2 charges for micro instances are free for up to 750 hours. So ultimately, you'll have to go to this thing called console.aws.amazon.com, and this is where the whole fun starts from. Okay, so as I said that the cost actually depends on where you are running the instance. So let's choose US East. There are plenty of options to choose from. So some regions are not available for us, but I really don't care where it's running. Okay, sometimes for privacy stuff and so on, people do decide on where the hardware should be sitting in case for data security and so on. But for us, we don't care about those things. So earlier the number of options available were few. Now it's so large that it gets a bit overwhelming sometimes. But once you get used to it, you'll know which buttons to click. So you usually look for this orangish button. That will take you to where you want to go. Okay. Let's move on from the slides to this one. As I said, you need an AWS account with the credit card details, which I already have put in. Now, well, let's start a new instance. So for this, some information on this console. Again, here you have lots of stuff available. You can see images, you can see storage and so on. And then I'll click instances here, which says that there's no instance because I tried out a few, but I deleted them just to be sure that if some instance is already there, it might be running and it might keep charging me. So what we do is we click this launch instance, but then since there's nothing here, so then you have to start a new one. So let's start a new one. So for this we'll have to search for what is the machine image you want to build on. So I'll want to build on Ubuntu, and then Ubuntu has some options available. Now it's telling me that these two are free tier eligible. So let's filter on that. So this is Ubuntu Server 2404 LTS. Okay, so this is 2404, this is 2204. So let's go for the latest one, 2404. Okay. It's x86 architecture. Okay, so that's the one I want. Okay. So this is your machine instance. Now where you want to run it? So I'm running it on T2 micro because T2 micro was free tier eligible. Okay, so this is good. Now it says key pair. So for this, what we'll do is we'll have to create a new key pair. Okay. So we go to RSA PEM. That's good enough. Let's name it. So this is how you will authenticate when you want to log in, and now we'll have to save it. So it basically has to go in the same path where you will be SSHing from. So I'll put it in a folder called AWS that I already have created. So remember that you'll have to use this key that you have downloaded. Network settings, you can read about these things. So you want SSH traffic. Now you can also select. So I can hear you if you talk in the class. Okay, so thank you for not talking. So SSH, we'll be SSHing to the server. So in that case, if I want to be extra secure, I can say my IP. So it has already detected my IP. So in that case, I can only connect to the service from my particular IP, SSH to it. But in this case, I don't care. It's not a very secure thing anyway. So anywhere, I mean, whoever knows, has the key and so on, can connect to the server. Now I also want to have some web services possible because I want to develop a website. So I'll say allow HTTP and HTTPS traffic as well. So this makes it more vulnerable, but it's only for demonstration. So you can enable it. So I am getting 8 gigabytes of storage on whatever general purpose SSD, which is fine. So up to 30 GB on general purpose SSD is free. That's it. So now it tells me a summary. I'm running canonical 2404 Ubuntu LTS T2 micro with 8 gigabytes of storage, and it tells me what's free. Okay, so that's pretty much it. You click the button and it launches. Okay, so it says successfully initiated launch. Now we can go to instances from here. And I think I'll have to refresh here, and now you can see that there is one instance with this instance ID that is getting launched. So it's pending. It's like you're setting up a new machine. It tells me some details like public DNS and so on, and as it launches I'll get more details. So it has some IP, some DNS. So I'll need this. It's a public DNS. That's how you connect to this machine. That's how you talk to it. So I need this IP or DNS, whichever I want, to connect to it. Okay. It has a key name because if I have multiple keys in my folder, I'll have to remember which key to use. And it also tells me what time it was launched and the platform. So I can actually click this instance. Now it's running. It says running. So I can now click it, and it tells me more details about it. Okay. So it's running. This is the public IP address, this is the private IP address, this is the public IP DNS. I can literally just click this button to copy this whole DNS, and then it tells me some more details which I'm not worried about right now, but you can see that it has networking and so on. In fact, I can do things when the instance is running. So if I did not select or I did not enable HTTP and HTTP access while the machine is running, I can enable the access. So you can increase things. So it's quite elastic in that sense. Okay. So let's connect to it now. So for that I'll need SSH. So I have SSH available through my WSL Ubuntu that I've installed, but you can have any machine which has SSH installed. So I go to AWS because that's where I had stored the key. So you can see that this is the key I had stored, HPSC class AWS.pem. So the way I connect to this machine is, in fact, it should give me some suggestion. If I click this connect, it tells me there are different ways to connect. I'll want to connect through SSH for now. So it says open an SSH client, locate your private key, and then you run this command, which let's not worry about that. So in the end you run this command which says SSH followed by -i, that's to give this key, and then you say username, which is Ubuntu @ the complete public IP. So I can literally copy this, and that should be enough. I think the permissions, it says chmod 400. Right, so it's connected. So now you can see Ubuntu at this IP. So now I am at Amazon Web Services server where these things are running. Okay. So let me show you what all it printed. So it gave me some information about system load, how much of, so I had taken around 8 gigabytes. So it says 23% of that, well, it shows some of it is gone in root and so on. 20% memory is being used, processes, 105 processes are running, and 0 users were logged in before I logged in. Okay. So this is the status. I can do an ls -l, and well it might seem a bit slow because it's connected through network. I'm SSHing, so it depends on how fast my network internet connection is, but usually unless I am enabling some graphics transfer, then it's fast enough. Okay. Let's see. So now we'll have to install some stuff before I can actually show you some demonstration. So for that, let's see if Git is installed. Well, Git is installed, so I'll say git clone https. So I'm cloning the class repository. So internet is lightning fast on the machine. So it's installed. Let's go to this repository. So let's run the lecture 1 code. Okay. So this is the lecture 1 code. So we'll just run the makefile to generate those graphs. So before that, I'll have to install a few things. So I'll have to install. I'll have to do sudo apt update. These things typically take a lot of time if your internet is slow, but on this the network's pretty fast. But remember, this is happening on their server, not on my local machine. So I need to do update to enable some, because it's 2404, that's very latest, so I'll have to update those. And then I'll do an upgrade. So it upgrades the latest packages. Otherwise what happens is venv is not available if I don't update and upgrade for Python 3 on 2404. So now I'll also want Fortran because we'll be compiling the code. So I'll do sudo apt install G Fortran. Okay. Again, that's going to be very fast. And then I need to create a virtual environment because I'll want to plot things and I'll need matplotlib. So for that I'll have to create a virtual environment and have basically do a pip. So I'll do sudo apt install python 3 -venv. What I love about this is the internet is so fast. You do a sudo apt install and that happens instantly. I'll need make because I'll be doing make. Well, you can write all these in one line. Okay, I am just doing it because I'm discussing that. You can literally like sudo apt install and then all the repositories and press enter. I also want to have a web server. I want to develop a website. So Apache 2. Okay, so that's yes. So now my website has also been installed, and that will enable the service as well. Well, how do I connect to this website? That's easy. I can go back. I know this public DNS, so I'll just copy this, go to the browser and paste and press enter. So now it says, so that's a default page on the website. It says Apache 2 default, it works. So that means I'm able, the website is working. All I have to do is I have to replace this web page with whatever I want in the folder and that will open. Okay. So this is the website, that's the service address. So that's this is something that's good about these things as well. You get network connectivity. Right. So let's go back. I think I've got everything that I need installed now. It's clear, and do a make. Done. So it says the exe has been created. So then I think let's have a look at makefile. So jacoby2.exe was is the executable, and then I can also do a make plots, which basically first ensures that solution.txt is available, which is generated from jacoby2.exe. So all basically I have to do a make plots and that should work. So make, and the target is plots. So it first runs the code on Jacoby, this executable, and this code which now you can actually understand, it's an OpenMP based parallelized code. It demonstrates by running first on one thread. It takes 10 seconds. Now if it runs on two threads, it should take elapsed time should be half of it. But in this case it's actually slightly more because my instance only provides one CPU. So OpenMP was able to create two threads, but both of them were running on the same core. So what happened was the same core ran the first thread and then it ran the second thread. So the overhead of creating threads was actually more. So in this case, if you're trying to create two threads and running it on one core, it ends up running slightly slower. But that's okay. I mean, in principle it works. I can simply change the instance type from one CPU vCPU to two vCPU and then it will work in half the time. But I don't want to pay for that for demonstration, so I'm not doing that right now. Okay, so it says make some plots problem. Python not found. Okay, we didn't create virtual environment. So let's go into the home directory, do a Python -m venv. So that, sorry, Python 3. So that should create the virtual environment. Now we'll activate that. So this active, you can see that now, and now I can do a pip install matplotlib. Again, that should happen very quickly because the internet is fast. So that's installed. So now we can go back to our previous folder. Let's do a clear. So you can now see that let's do a make plots again. It won't repeat whatever it's done. So now it's only plotting, and now it says it has created pcolor and contour.png. Let's do an ls -l. So we see that the results are finally plotted in the form of these plots, which are two image files. Now I want to have a look at them. One way is I can download it, okay, onto my local machine. The other is, since I'm already running a server, I can move these files into wherever the server is installed. So that's default is var www/html. So I moved it there, and now if I refresh, let me rename this index. Right, so now you can see that it shows this contour.png, which I can have a look now. And remember, this is just a web page. Even you can open this link, it will open for you on your machines. There's no key or anything, it's a public web page. And p color. Okay, so you can do whatever. I've just given you in principle what the functionality is, and now you can do whatever you want with it. Now, if you want to copy it, you just have to use SCP, because we did SSH secure shell. So you can do an SCP. So all I have to do is simply remember I have to go to the same folder, because I need that key. There's no password that it asks, it's only through key pair. So I have to do an SCP with a -i, and then this, and then I have to say @, colon, and then the path from where I want to copy. I had actually moved this into this folder which has a root access. So let's copy these back into the home just for demonstration. Okay, so if I go do a cd ls, so in the home I have contour.png on my instance, which is running on the Amazon web server. So I can simply say this colon contour.png . So this should connect and then copy contour.png onto my local machine, which I can now, using display command, should open the image. So I've recorded this in case you want to have a look at it. But this is amazing stuff. I have paid my own money to use this service for computing. You don't have to rely on your local machine running all the time, because there's no power and so on, or you want to travel, and you can write all sort of scripts here, and your supervisor will get an email when the codes have run, and you can literally, I mean, this is you can open it on your mobile phone and simply SSHing from there. So there are other ways to connect as well. So this was Amazon Web Services. Now if you want to export graphics, do that. So let me disconnect. So I've disconnected. So all you have to do is you have to do a x11 forwarding. So you do a -x, capital X here, and then if I say contour G, well, so I need to install this image magic to enable the display command. So that should display it, but then the graphics will be ported to my local machine. So that process is a little slow. It's always good. I prefer this web services where I can put everything in one folder, and then I can literally refresh and then click that image, and that or whatever it opens. So now I can say display contour.png. As I said, it's slow. Sometimes very slow. Okay. Any questions on AWS before I move on to Google Cloud? I'll do the same thing, but very quickly on Google Cloud now. Good. There's no question. Let's see if Still working, okay. Let me cancel it. So when you're done, you do an exit. So you've disconnected from this machine. I'll just close this. Now I also want to make sure that it's still running. I just have disconnected. So you go back to your list of instances. So always good to do a refresh just to make sure sometimes it does not refresh. So it says it's running. So there are also ways to figure out how long there's a lot of analytics that you can have a look at if you have lots of different machines and so on. So now what I'll do is I'll just click it, and I would want to stop the instance. So what happens is when I stop it, it will stop charging me, but the instance will stay in case I want to run it again. Just to be double sure, because sometimes if the instance is taking some storage space, a lot of storage space, and they're charging for storage space because the information is still sitting, the storage space is still with me. Even if I switch off, stop the instance, in that case the storage will be charged. Just to be double sure, I don't want to use this instance any time again. I'll delete it using the terminate option. So it says if you terminate, everything will be deleted. That's okay. So now it will terminate the instance. Now I cannot use it again. I'll have to set a fresh new instance. And again, there are ways to share instance. Once I create one, I can share that with people through a link, and they can click the link. When they are setting a new machine, they can just start from that instance. And with that instance, they can actually increase the computing power. They can do whatever they want further with that. Okay. So this was Amazon Web Services. Now let's go to, and you will see that Google Cloud Platform it's very similar. It's as if they just copied it. So let's go to the console, which is similar to what the Amazon Web Services console looked like. I have 2 accounts because I have a college account, so I have to make sure that it opens the right Google account. So what I'll do is I'll put it here. So that should hopefully, so that's my private Google account, which is connected to my credit card. So you will see that it looks like this. So instances and it also has TPUs for machine learning simulations and so on. So you can see it's very similar. Okay. There is also a free tier link here. So you click this free tier, and it tells you that this is free tier. When you start an account, they give you $300 worth of computing credit free. So that's what free means in Google Cloud, not hours but some amount of money, and equivalent amount of. So if you use the resources, you will end up using. So so $300 is around 24,000 rupees. So I can go back, and it tells me on the top here that 25,000 4 rupees are available for 90 days. So this is not 1 year, this is 90 days. Okay, and they also hope that I'll click this activate, and then my account will get permanent. But here, if you don't activate the account, then after 90 days the account gets disabled. So that's the good thing, they will not charge you unless I press this activate. So free tier things I can use. So again, what I have to do is I have to click on the, so I am on the console now, console.cloud.google.com. So I click create instance, and the process will be very similar. Now another thing to be careful about here is that free tier products are very specific. So let's click the compute engine free tier products here. So they say that this E2 micro VM is free per month only in these regions. So Oregon, Iowa and South Carolina. So US West 1 is definitely free. So first I have to select, so by default it is US West 4, okay. So now it will start charging me. So this is US West 1, Oregon is free, so I can select this. I don't care about the 3 sub zones here, that's okay. And then it said E2 micro is free, okay. So I go to this E2, and then within E2 I'll select micro. So this is E2 micro. So now I'm happy that well, E2 micro has 2 vCPUs. Okay, so now actually we can run this OpenMP code. It should hopefully work. So let's double triple check this. So this is the instance ID. You can rename it if you want, but I don't care. It's US West 1 E2. So again, there are many other series available depending on the application you have. So typically you can even have CPUs on the less than 1, so 0.25 of a CPU. I don't know what that means, but I think that's based on some gigahertz because it's a virtual CPU. So if one CPU is 1 gigahertz and 0.25 CPU is 0.25 gigahertz of computing of the clock speed. Okay, so this is E2 micro, and then VM provisioning model is okay. Then a boot disk is where I'll select what OS etc. I want. So I want Ubuntu. So Ubuntu, and then which version? So let's go for 2404 LTS. So again there are. So this is x86. This is ARM. So let's go for x86, and then 10 GB is enough for me. Select. Okay, so I don't want to have any service account with this. Don't worry about this. Again, this time we want to have a firewall. I want to allow HTTP and HTTPS traffic so that I can run my website, and that's pretty much it. If I am happy with it, then I can click the button create. So very similar. You see that the user interface is very similar, and it makes sense because people who are using AWS have shifted, will want to shift to Google Cloud. So why not give them similar interface? So then it gives you more buttons here for billing reports, monitor virtual machines, set some firewall rules. There's plenty of stuff you can do. I don't remember anything. I just, whenever I need something, I'll Google it and it will give me the stuff to try on. So let's retry or refresh. It takes some time to start the instance. Or did I press restart? I should have pressed this refresh. I think I restarted the instance again. Okay, so now it has started. The zone, it has an internal and external IP. It also has this connect. Okay, so it's I think it's restarting now. Okay, it says 10 GB PD balanced disk is currently unavailable in the US West 1B zone. Please try your request again in another zone. Okay, so this also happens. So dismiss. Let's try the C zone, or maybe let's US Central 1, let's try that. Yeah. So I won't speak up, I'm doing the same stuff again. So you can also import the VM, import this onto your local machine and play around with it. Good, so this is green. So it's running. Let's click this. Let's see what it tells me. So now to connect it, I can drop this down. So there are different ways to connect it. Open in browser, open in browser. So I can also run it in browser. I don't need to do any. So if I'm running it on a phone, let's say, let's click SSH. Everything will open in a browser. So it will do all the authentication, etc., over the browser. That's it. So it's connected. Increase the font size. It does tell me, it's again very similar information that I was getting earlier. Let's clear the screen, do an ls, nothing is there. So git. So this time I'll install everything in one go. By the way, if you want to run MPI as well, so you can just apt install OpenMPI -bin, and that will allow the use of MPI as well. So now it's installing the Apache server. So for that we'll need sorry, it's running here. So I'll need the IP for that. So I think that should work. External IP address is what you'll connect to. So let's try that here. It works. Okay. Good. So it's done. Let's increase the font a bit. So HPSC is there. So let's go into this codes, Fortran, lecture 1, and make. Then make plots. So hopefully this time, since 2 virtual CPUs are available, it should show a reduction in the runtime, the elapsed time. It's definitely slower than that. So maybe they give you 2 CPUs, but the clock speed is much slower. Let's explore that. Oh, so it took 47 seconds. I think that one took 10 seconds. So definitely lower clock speed. As far as I remember, when I tried it on for practice, it was a little bit faster than this. There's some problem. Okay, it took 83 seconds to do with 2 threads, which definitely doesn't make sense. But anyways, we don't care about that. I don't want to explore that right now. I just want to demonstrate the service to you. So then it could not plot because the virtual environment is not. So let's do Python 3 minus m venv. When I tried it on a different. I tried it in Ohio, so maybe that was faster. Internet also is slow on this one, but I think you get the idea now. Okay, so I'll stop this here now. So once you make the plots, you can put the files in the same folder on /var/www/html, and then you can refresh on your browser and you should be able to see the plots there. So let's cancel it, but remember, always remember to disconnect. Oh, sorry, always remember to switch off the machine. So if I refresh it, sorry, not reset. So okay, so there's an option to stop, suspend, and delete. So let's stop it first. And then I will select and delete it. So that will delete it altogether. So then this machine will be gone. Okay. Any questions? That was an intense 1 hour session, but hopefully you've been able to get something out of it, and you'll feel more confident if you have to run codes, not depending on a slower laptop or not the cluster not working. So if you are being paid the amount of money to run these resources, you can practically run it now.